everyone, welcome to the Somnia Developer Education Series, Somnia 101. In this session, we're going to learn how to use ERC20 tokens on Somnia. Let's get started. I've already set up an ERC20 token here that inherits the properties from this interface and makes it available to any smart contract that want to interact with it. Alternatively, you can set this up using the Zeppelin library. So we have a couple of basic functions that every token requires: the transfer, the approve, and the transfer form, and the ability to meet and bond. So we are going to build out our application and deploy this ERC20 token, and then call the deployed contracts in our smart contract to be able to interact with it. So for this particular smart contract, we would need three functions basically. The first function would be to buy an item. The second function would be to withdraw tokens from the smart contract. The last function would be to get the smart contract balance. To be able to use the deployed ERC20 token in the smart contract, we'd have to inherit the properties of the token via an interface, which I'm going to paste. So we have basic characteristics in here: the transfer form, and then the ability to read the balance. And then we'll start by writing our smart contract. And then the Somnia ERC20 shop. So a couple of things that we need from our smart contract. First, we have to set a user type, which is the owner of the smart contract. And then we would have to inherit the deployed token via an interface, and we'll call this game token. So having done that, for the items that will be on sale, we have to list them. This public item, price, and each item will be worth 100 of the game token. So 18 decimal places when the game token is deployed. And we want to be able to track the items sold. We'll go ahead and set up the constructor for our smart contract. It's going to take in one argument, and that is the game token address. And we want to set the owner when we deploy the smart contract as the message.sender, and of course we want to pass game token to the interface. That is the game token address. This will make it available to us in the rest of the smart contract. So having done that, we have three functions. The first is the buyItem function. It's external. So the second is the withdrawTokens function. So on the external side. Then the last but not least is the function to get the contract token balance. So this is a view function. That means it doesn't change the state, so it just simply returns the balance in the smart contract. So that's the data type. So for the buy item, what we want to be able to do is to transfer from whoever is calling this particular function, and then transfer the amount for the item price into the smart contract. So for that, we are going to be using the transfer form. So the transfer form basically takes in three arguments: the sender, the recipient, and then an amount. So as you can see, back to our example, right, we are going to have to check first of all, using the require statement, that when we call game token and call the transferFrom method from it, we are passing in three arguments. First is the message.sender, then the receiving contracts, and of course the amount, which is this instance is the item price. So this helps us conduct a check at the same time, right, while we are calling it, and we can simply set up an error message if something goes wrong. So after doing that, we want to, of course, increase the count of the item sold because we are tracking it. I want to increase that by 1, and we want to emit an event, which we'll come back to. So the next function is the withdraw function. For the withdraw function, we also want to start with a check. We want to ensure that anyone calling this function is the owner of the contract. If that is not the case, we'll return an error message saying only the owner can withdraw. So having done that, we want to set a balance variable and set it to the game token, returning the balance of the address of this particular smart contract. So setting the balance that way, we can then conduct a check that the balance must be above 0 before we can withdraw. If that is not the case, return an error message. And if that is the case, we want to ensure that we check that the game token transfers from, because the game token transfers to the owner the balance. And if that doesn't happen, you should get an error message saying the withdrawal failed. And in an instance where that happened, then we should emit a success event. So you'll notice that this uses transfer, while this uses transferFrom, right? So this is because for the transferFrom, taking 3 arguments, anybody can call this function, and then this particular smart contract is able to interact with the ERC20 contract, calling the approve method, and then being able to trigger a withdrawal on the behalf of the message of the user. So for the withdraw tokens, we just call the transfer method that takes in only 2 arguments because it is only the owner that can call this particular function. So just a quick look up of what transfer looks like. You can see that it takes in 2 arguments, just the recipient and then the amount. So going back to complete our last function, we just want to return a balance of the smart contract by checking the balance of the amount of the game tokens that this particular smart contract holds. So we're almost done. The last thing we have to do here is to set up a series of events that we can use to track our functions. So we're going to have 2 events to track the buyItem, which is the item purchased, and then to track the withdrawals made using the withdrawTokens function. So the first event is going to be item purchased, and we are going to be tracking the buyer and also the amount that was paid by the buyer. And the second event that we are tracking will be the tokens withdrawn, and we are ensuring that we take record of the address if it ever gets changed, and also the amount that was sent. So we can now update our events. Here we are emitting the items purchased events, and we are passing in the message sender, which is the address of the buyer and the item price. So, and for the withdraw tokens, we emit the tokens withdrawn, rather, passing in the address of the owner and the balance variable. So we're done with the smart contracts and it auto compiles for us. So the next thing would be to deploy and carry out transactions. We're going to start by deploying our token contract. So I'm going to connect with the Somnia network and I'm going to deploy this token, call it the manual token, symbol will be M, and I want it to have 18 decimal places. So deploy this smart contract. It's going to prompt me to approve it on, confirm it on MetaMask. So that contract has been successfully deployed, and here's the contract with all the methods. I'm going to copy the contract address and then deploy the shop contract by selecting the shop contract. It only requires me to pass one argument, which is the ERC20. So this is where interacting with native STT differs from interacting with ERC20 smart contracts on Somnia. So with native STT, you do not have to deploy a smart contract. STT does not have a smart contract. It is native to the network, so that way you can call all methods transfer on your EOA or your smart contract wallets without the need to call approve and then the transfer from methods. So but with ERC20 tokens, you'd have to do that. So deploy the Somnia ERC20 shop, confirm the deployment. So we now have two smart contracts here, the ERC20 contract and the Somnia shop contract. But to be able to buy an item from the Somnia shop, we first of all have to carry out a couple of steps here, and the first would be to mint some tokens to our address. If you currently check the balance of the address, you see that it's 0. So I'm going to mint 100 of the M tokens. Right, I'm just going to copy that from the item price, mint 100 of the M tokens. So remember that it is 18 decimal places. Means to this address. So the balance is 0. Call the mint function. It's going to ask me to approve that. Approve, confirm it. So that is successful. Check the balance now. It has changed. But to be able to call the buy item, if I call it right now, it's going to throw an error. Because first we have to approve the Somnia ERC20 shop smart contract to spend the game token. So if I call the buy item, it's going to trigger an error. So cancel that transaction. So what we want to do here is to approve the smart contract to spend on our behalf a certain amount. So copy the contract address, paste it in as a spend into the approve, and then approve it to spend 100 of the game token. So call that, confirm it, and then after we have approved the contract to be able to spend, right, first get the contract balance. You see that it is 0. The items sold is also 0. So call by item, which takes 100 tokens, confirm that, and then it returns a success response, right? So you can see that the items sold count increases and then our contract balance increases. So that is how you interact with ERC20 token contracts on Somnia network. And with that, we have come to the end of today's lesson. Thank you for watching to the end of this video. Kindly leave your questions, comments, and feedback. You can also ask your questions on Discord in Dev channel. I'm always available to answer. Like this video and subscribe to the channel. See you in the next one.